Lesson 1, using properties of real numbers. From here till probably about at least lesson 10, everything here should be review, right? We should know all this stuff. In fact, a lot of what I'm covering here, I just got done covering with Algebra 1. So how do I know it's review? Because it should even be review for Algebra 1. Okay, we're talking about real numbers. Real numbers. Real numbers as opposed to what? I mean, if we didn't have something that was the opposite of real numbers, then we wouldn't even need the term real numbers. What's the opposite of something that's real? Not irregular. That would be the opposite of something that's regular, right? What's the opposite of real? Do you have real friends? You might also have fake friends, but that doesn't mean that they're not real. They're real people. My daughter has these. She has real friends and she has imaginary friends. We have real numbers and we have imaginary numbers. Examples of imaginary numbers are like the square root of negative numbers. All right, they're not real in a real sense. Okay, it doesn't mean that we can't work with them. In fact, when you get to Algebra 3 and even later on in this class, we'll work with imaginary numbers. You'll even see that your calculator will work with imaginary numbers if you look at the little symbol above the period on your graphing calculator. Has a little letter I. Okay, that's not I as in, the letter that comes after H. It's I as in imaginary. So I don't want to waste a whole bunch of time telling you about imaginary numbers. I just want you to know that there is something that's opposite to real, and that's why we have to use the term real. Otherwise, we wouldn't have to. Everything would be real. We wouldn't have to define it. So real numbers consist of rational numbers and irrational numbers. Irrational is not the same as imaginary. Irrational numbers are numbers like what? Pi. What's unique about pi?
It repeats, but it doesn't repeat the same thing over and over.
So it doesn't repeat, okay? It doesn't repeat and it doesn't what? End. All right, so an easy answer on irrational numbers is that they are going to be decimals that do not repeat and do not end. Okay? Rational numbers include whole numbers like 0, 1, 2, 3, and so on, and integers like -3, -2, -1, 0, 1, 2, and 3. Okay, those are integers. All right, so rational numbers include those. Okay. Rational numbers can be written as quotients or fractions, not quotients of fractions. Let's go ahead and fix that. Okay. Okay, meaning that a rational number is the quotient of two integers. Okay. Rational numbers can also be written as decimals that terminate, which means that they end. Okay, or repeat. So it has to be one of those two. For instance, 1/3 is a rational number. Even though whenever I plug it in my calculator and I hit enter, I get a decimal that doesn't end. It's 0.3 repeating, but because it repeats, it's rational. Does that make sense? You might even, and then let's say I had, just a decimal that ends like 3/4 is 0.75. It ends. Okay, it doesn't repeat, but it does end. All right, so it's rational. Then we have our integers, which include our negative whole numbers. Well, our negative numbers and our whole numbers. Our whole numbers include 0 and all our positives, natural numbers, and so forth. Okay, irrational numbers cannot be written in any of these ways. Pi and many roots of real numbers are common examples of irrational numbers. Pi, the square root of a prime number, and e. And I know that's written really small, but you have those examples. We'll get to working with e again towards the end of the year. You'll get to see some things with e. All right. We feel pretty good about that? Good. All right. I'm going to admit that my voice is sore. I'm not used to, talking this much, this long, and so I'm kind of getting my teacher voice back. There are a number of properties that can be used when adding and multiplying real numbers. So you're going to see those properties on the left and how they affect addition and multiplication. So we would call the first one the closure property of addition or the closure property of multiplication, meaning that a plus b is going to be a real number, okay, just so long as I'm adding real numbers. A times b is going to be a real number, okay, so long as a and b are real numbers. Commutative property, you're probably familiar with the commutative property. Commutative property just means I'm able to, whenever it's all addition, I'm able to switch all the numbers. I can move those numbers around in any order so long as that it's all addition. So a plus b comes out as the same thing as b plus a, and it works the same with multiplication. So long as it's all multiplication, I can change the order. For instance, if and I'm going to put this on the board so you won't be able to see it in the video, but if I have x, y, z, this is all multiplication, right? Could I write that as z, y, x? Would it be the same thing? Okay? Or x, z, y. It doesn't matter. I can change the order. It's commutative so long as that it's all multiplication it's being operated on. If it was x plus y plus z, I could write that as y plus x plus z or z plus y plus x. It doesn't matter, but that works with addition and multiplication. So that's what we call commutative property. Associative property allows me to move the association or the parentheses around, again, when it's all multiplication or again when it's all addition. So a plus b plus c is the same as I'm going to add a plus b, and then I'm going to add c after that, or I can add b plus c and then add a after that. Okay, it's just the association. The same thing works with multiplication. You guys can see that. The distributive property, you'll notice it's not the distributive property of addition, and it's not the distributive property of multiplication. Distributive property can use both addition and multiplication, meaning that I'm going to distribute the a to the b and the c. So it's a times b plus a times c. And distributive property is one that you're going to see, you should have already seen. You guys are familiar with the distributive property, correct? Okay, again, I'm not giving you anything new, anything that you haven't seen. One thing, I guess I forgot to mention this when we were looking at your Google Classroom. I sent you a link to our class Quizlet page. How many of you have used Quizlet? It should be just about everybody in here, evidently except Eric. That's fine. Let's see. But what's going to be a good practice for you if you want to do this personally, I'm going to try to, again, finding time to do these things. It's not necessarily that I can't do them or I don't want to do them. I just have to find time to do them. Is basically taking this information and making flashcards for you, so as we get ready for tests, you guys can quiz yourselves, or we can even kind of compete as a class against each other to find out, who really knows what. So I'm going to work on some of that at least before we get to our test time, okay? So we also have identity properties and inverse properties. In an identity property, what our goal is to get what we started with. So in addition, we're going to, it's a plus 0 is going to leave me with what I started with, which is a. In multiplication, it's multiplying something by 1 is going to leave me with what I started with. So let's replace a with a number. Give me a number that I can replace a with. 1. Okay, so what's 1 plus 0, John? 1. I got what I started with. Just is a little hard on the multiplication side, what's 1 times 1? 1. But it's the one that I started with. If we change it to maybe something different than 1, let's say we changed it to 3. 3 plus 0 is 3. 3 times 1 is 3. Okay, so do we see how identity properties work? With addition, it's 0. With multiplication, it's 1. All right. Inverse property means that in addition, I want to get 0 this time. Okay. In multiplication, I want to get, again, what I started with. So the inverse property of addition means that I add the opposite of what I have. So if I replace a with 3, I want to do 3 plus negative 3. That's going to get me 0. If I switch out a with 3 on the multiplication, I would do 3 times, actually what this should be, let's see, should be 1. I don't know if the book is wrong on this, because I think I went pretty much straight from the book on that. Yeah, yeah, that is wrong. It should not be A. It should be 1. Because, let's say I've got over here, and I got 3 times 1/3. Okay? What happens with the 3's? They cancel out. What am I left with? 1. Okay? So, and the same thing would happen with, essentially, if I've got A, and I want to write that as a fraction, I'm going to get A over 1 times 1 over A. Okay, so I get 1A over 1A. The A's cancel out. I'm left with 1. Okay, do you see that? So there is I would say that that is an error in your textbook. Okay, that it should not read as, oh, you're looking for Reagan. She was in I sent that email out like, I don't know, a couple of class periods ago. You might be able to contact the office and find out which class she's in now. I don't know where she's at right now. That would have been, it was the last hour, I think. So anyway, sorry. Yep. All right, so there is an error in your textbook if you're looking at the top of page 4 where it says A times 1 over A equals A. It does not. With inverse properties, there we should be getting 1 on multiplication. So it would be 4 times 1/4 equals 1. Okay? All right, and I think that that's the end of that. So what we'll look at from here is we'll look at some questions that we're going to try to answer. All right, what property is being demonstrated by 8 times 1/8 equals 1? That should be familiar to us because we just got done looking at that. The inverse property of what? Of multiplication, okay? I know it doesn't say of multiplication, but that's what's happening because it's not the inverse property of addition. In the inverse property of addition, we would be getting 0, okay? All right, number 2, we have this number. It's the square root of 37 over 4. Is that rational, irrational, or not even a real number? You say it's rational? Somebody says not a real number. If it's not a real number, what is it then? We would say it's imaginary, right? Well, in an imaginary number, typically speaking, you're not necessarily going to get an answer in your calculator. So square root of 37, I should be able to type that in my calculator and then divide it by 4. And I get 1.520690633. Is that what you got? Okay. So this is what I want you to see about this, is that you're probably not going to see a lot of imaginary numbers for a while. So not a real number is probably not something you're going to need to worry about just yet. So the question is it rational or irrational? This is one of the hints to something being irrational, is that if I have the square root of a prime number, that number is going to be irrational. And if I take an irrational number and divide it by a rational number, I'm still going to have an irrational number. That's like taking pi and dividing it by 4. Well, 3.14159, so on and so forth for eternity divided by 4 is still some crazy weird decimal, right? Okay? So square root of 37 is irrational. Divided by 4, which is rational, is still irrational. And you see that in the decimal that you found when you took square root of 37 divided by 4. Does that make a little bit more sense? Okay, so don't necessarily jump to imaginary. Let's see. Let's look at this property. I've got 3 parentheses 5 plus 2, but that's coming out to be equal to 15 plus 6. Can anybody tell me what's going on there, Danielle? The distributive property. What is being distributed? The 3. We're distributing the 3 to the 5 and distributing the 3 to the 2. That's giving me the 15 plus the 6. Is everybody on board so far? Okay. All right, number 4. This says write. I don't really like this type of question. It kind of bugs me a little bit. Write 9 times 39 using the distributive property, then simplify. There's all kinds of different ways that you could do that. I think ultimately we're looking for the one that has the correct answer, which is end up going to be the easy way to check these. Like, let's say that type of question showed up on the test, is take 9 times 39, because notice that they have the answers off next to them. Is it 351? Yeah, so the only one that can be right is this one. But the other thing that you want to see is that the numbers that are in parentheses need to add up to 39. 40 plus negative 1 equals 39. We could have done that a number of different ways, though. I mean, you could have done 9 times 41 plus 9 times negative 2, right? And keep doing that. And you should always wind up with 351. Okay? Okay. All right, let's scroll down to number 5. All right, number 5. Let's see how many total questions we have. We have 17. I'm not saying that we're going to do all of these, but we'll get at least a start on it. Finding additive and multiplicative inverse, and this shows up really funky. So that should be negative 2/3. I know it doesn't look like that. Sorry about that. Negative 2/3. What is the additive inverse of negative 2/3? Again, it should be something that I'm going to add to it that is going to equal what? Additive inverse. 0. All you got to do is go back and either look in your book or look in your notes. You'll find that at the top of page 4. It's a number plus itself, or a number plus a number like itself. It needs to equal 0. So negative 2/3 plus what equals 0? 2/3, right? It should be the opposite of whatever number I'm working with. Okay, so if this is negative 2/3, I'm going to add the positive equivalent. Okay, so we should get 2/3. And what is the multiplicative inverse? What am I trying to multiply it by? What do I want it to equal? 1. Okay, I want it to equal 1. So what do you say? 3/2. Yeah, it should be. Actually, though, here's the thing with this, is if I want it to be equal to 1, yeah, I've got negative 2/3, and I want to multiply it by something, but I want it to be equal to positive 1, right? So if I'm multiplying a negative times something and I want it to be positive, what kind of number do I have to multiply it by? A negative number. And then I need the reciprocal, correct? Which I think is what Eric was saying. He said 3/2. So negative 2/3 times negative 3/2, the negatives cancel out to be positive. 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is 1, right? Do we see how that's going to give me my multiplicative inverse? Okay. All right, very good. You guys are on top of it. All right, let's see. When you get to something like number 6, it says you use mental math to find the 11% tax on $25. One, you could take 0.11 times 25 to find that. What they want you to do with this, though, is they want you to imagine this first as 10% and then as 1%. So what is 10% of $25? Can you tell me that? $2.50. All right. 1% of $25 is going to be 25 cents, right? So I have $2.50 plus 25 cents. What's that going to be? $2.75. You see how they intend for you to use mental math there? Okay. And again, they didn't really talk about using mental math a whole lot in the lesson. All right. We could go through all the rest of these. Like I've said before, though, these questions and all their answers are at the bottom. What I would rather do, rather than trying to answer every single question that's on here, is go ahead and let you get started on your homework and be able to walk around and see what questions you have from there. Okay, does that work for you guys? Okay, because I think that you're out of here at like 10:36-ish. Let's double check that. Yeah, 10:36. So that gives you about 15 and 6. It's 21 minutes to work, which I think is a pretty ample amount of time. So I'm going to hit stop on this, let you guys get to work, and then I'll be around to answer questions as you have them.